Good afternoon, everyone. First of all, I warmly welcome you all to the third semester. So, this is your first video lecture on Unit 1, that is Classical Algebra. So, I have given you the book reference for this unit, or you can refer any book of complex number. So, our first topic for this unit is complex number. First, we see the definition of this complex number. A number which is in the form x plus iy, where for all x comma y belongs to the real number and the small I equal to root over minus 1, that is called the iota. Now, to go further, let us see the brief history of complex number. Okay, so how complex number developed. Okay, if we see this figure, in this figure, if we consider the side of this triangle is 3 and the side of this triangle is 5, then if we have to calculate the side of this triangle, and we know this 3 and 5 are counting number, or you can say these numbers are the element of natural number, then if we calculate this side by using Pythagoras theorem, then the side of this triangle is root over 34, which is not a counting number. So similarly, the development of numbers are increasing rapidly. Similarly, if we consider this circle, each fraction of each part of this circle, it's the fraction, and which is not a counting number. Similarly, now each fraction is the member of rational number, and this side is the member of real number. Okay, it means first we see x minus 5 equal to 0. So it has a simple solution, x equal to 5, and this is the member of natural number. Similarly, if we see x plus 2 equal to 0, we can get the solution of this equation is minus 2, which is the member of integer. Similarly, you can have this equation, the solution of this equation is half, which is the member of rational number. And if we consider this equation, then we'll get this solution, and this solution are the members of real number. Now, if we consider x square plus 1 equal to 0, then it has a solution x equal to plus minus root over minus 1, and we know the square root of negative number cannot be calculated. So in that situation, this value leads to small I, that is iota. Okay, now we see the origin of complex number. Now consider this equation, x square equal to mx plus b. Now this equation has a solution mx equal to m by 2 plus minus root over m square by 4 plus b. And if we represent this equation y equal to x square plus y equal to mx plus b in graph, then we will get this kind of figure, and the intersection of these two curves are the solution for this equation. Okay, now the main reason is if the value of this equation is negative, this expression is negative. It means if the value of m squared by 4 plus b equal to is less than 0, then in particular we can say if x square equal to minus 1, then it has no real solution. So in that period, the mathematician ignored this kind of equation because the development of complex number were not there, and if this kind of expression arises, they called as this kind of equation has no real solution, and they ignored that kind of equation in that time. But the main reason why complex number develops is, to develop a complex number, the main reason is cubic solution or cubic equation. So if we consider a cubic equation, x cube equal to px plus q, and if we represent this y equal to x cube and y equal to px plus q, then it shows that this figure shows that this equation must have a solution. It always must have a solution. Okay, so if we consider this figure, this is the curve of y equal to x cube, and this is y equal to px plus q. This shows that this line always intersect a point on this curve. It means it has at least one solution in this intersection point. So by using this, the mathematician showed that the solution for this equation given by this kind of, the solution of this kind of equation is given by this. Okay, this solution x equal to this. Now if we consider x cube equal to minus 6x plus 2, and if we tally this equation with this equation, then the value of p equal to minus 6 and the value of q equal to 20. If we put the value of p and q in this solution, then we'll get this, and we know the one solution for this equation is 2. Okay, now up to this there were no problem. Okay, but after 30 years, this man Bombele considered the equation x cube equal to 15x plus 4. This kind of equation, x cube, in place of p, he put the value of p equal to 15, and similarly he put the value of q equal to 4 for this equation. Then he showed that this equation has solution this. Okay, and he discovered this equation, cube root over 2 plus square root over minus 121 equal to 2 plus root over minus 1, and cube root over 2 minus root over minus 121, this is 121 equal to this 2, and he showed that this is equal to this and this equal to this. And after that, if we check, suppose this is not equal to this, if we check, then we'll get this and this. This is same as cube 2 plus minus 121 equal to 2 plus root over minus 1. Similarly, you can check this is equal to this, and if we add this to equation, then we'll get cube root over 2 plus minus 121 plus cube root over root 2 plus minus 121 equal to 2 minus root over minus 1 plus 2 plus root over minus 1. This cancel out, equal to 4. So this is the solution. Okay, now after that, the solution for this equation equal to this. Okay, so after this expression, the development of complex number begins. Okay, complex number begins, and they considered root over minus 1 equal to I, where this I is imaginary number. Okay, now for today I'm stopping here. From next video we'll see the algebra of complex number, some properties of complex number. After that we'll move on the next topic. Okay, so thank you all.